All right, so we are going to move into composition of functions, and we'll look at also at the decomposition of functions. So the composition of functions, so we have f composed with g. Just a second, my tool here. So like I said, we sometimes call this f composed with g, or we call it the composition of f and g, is defined such that g is going to be put inside of f. So what we're doing is we're placing a function inside of another function. So we're going to have the composition with f of g of x, where x is in the domain of g and g of x is in the domain of f. So we're saying that when we place that x has to be in the domain of g. Then whatever comes out, your g of x, that also has to be in the domain of f. If that's not true, then this x cannot be the domain of your composition. So just a quick example of what a composition is supposed to be. So we had said, so notice that's an open circle there for compose, not a closed one, so it's not the same as multiplication. So we said that what this is telling us is that I'm going to take f and I'm going to place the function g of x inside of it. So if I am given that fx is 3x minus 1 and g of x is x squared plus x minus 3, and I want to find f composed with g, well, that means that what I'm looking for is I'm going to have f and I'm going to put g inside of it. So if we look at f is going to be 3x minus 1. And we're saying here that x is being replaced with g of x. We know what g of x is. We have g of x over here. So g of x is just actually x cubed plus x minus 3. So this is all the composition is it's placing a function inside of another function. And we did something very similar to this very beginning of learning about functions. It was just very small things, like we would replace x with b plus 1 or something like that. This is the same idea, it's just a little more complicated functions. After we do this, we'd like to simplify, so we're going to distribute. Always distribute when simplifying, so that is 3x squared plus 3x minus 9, and then we have this minus 1. By like terms, 3x squared plus 3x minus 10. So this new function that we made, f composed with g, is just 3x squared plus 3x minus 10. Oops. Let me adjust my stuff here a little bit. There, now that's a nice straight line. Okay. We're going to put b over here. So b is g composed with f. So if I put f composed with g, that means g goes inside of f. If I have g composed with f, let me fix that one more time. That means that g is on the outside and this f is second, that is going to be on the inside. So this is always written as, this is always going to be the outside function is listed first, and then the inside function is listed second. So when it was f of g, f is outside, g is inside. If it's g, f, then it's going to be g outside, f inside. So we know what g is. G is x squared. So we're going to place that, just parentheses there, x squared plus x minus 3. So we know there's supposed to be an x there, but we're replacing it with f. And once again, we know that f is just 3x minus 1. And you just need a little extra space here. So what we're going to have here is that we're going to have, instead of f here, 3x minus 1 squared. Then this right here gets replaced with 3x minus 1. And then, like I said, we keep that 3 on the outside. So this is just 3x minus 1 times 3x minus 1. I think the worst part about this is simplifying, not necessarily the composition. And then we can drop these parentheses. So if we FOIL, we're going to have 9x squared minus, so you're going to have negative 3x, and negative 6x, and then plus 1. This here was just a 3x minus 4. We do this part right here and simplify. I simplify farther. I got 9x squared minus 3x minus 3. And this is your G composed with F. So this is really what a composition is. Like I said, it's just telling you we're placing one function inside the other. The actual composition, that was the actual right there, the whole composition part of putting G inside of F. And then this is just the composition of putting F inside of G. Everything that comes after that was just simplification, just because we like to have simplified answers. So reminder again, simplification. Simplifying an answer means that we are going to distribute if we can, so we can remove parentheses, and then combine like terms if we can, so we can eliminate some extra numbers and operators. Okay, so this looks the same, but look, there's a slight difference here that I'm doing F composed of G of 2. So there's kind of 2 ways I can go about this. So we just found out, because these are the exact same functions for F and G. Oops, let's use a little different color here. We just saw that F composed with G of X was 3x squared plus 3x minus 10. So all we're really being asked to do here is that if you already had found your function, is you're just replacing all your x's with 2's. So we're going to get 3 times 4, and then this is 6 minus 10. So this is going to be 12 minus 4, so this being an 8. So let's assume we did not find F composed of G first. The other thing that we can do is we know that G is inside, is that we would find G of 2 first. So if we did G of 2, well, here's G, so that would be 2 squared plus 2 minus 3, which is 4 plus 2 minus 3. So we're going to have 3 as a final answer. Now, if I want F composed with G of 2, well, that means really what I'm looking at is F of G of 2. Because X is going to be what's that, because G is my inside function, X is referring to whatever happens inside of G. So your X goes into G first, and then we get G of 2, which we said was 3. So that means F of 3, I have to figure out that next. So that is going to be 3 times 3 minus 1, or 9 minus 1, or 8. Like I said, you can do the composition of the function, but really what's going on here is that because we are looking for F composed of G, G is inside first, that X is 2, that means I have to find G of 2. After I find G of 2, then we are going to figure out that, once again, G of 2 is 3. That means we have to find F of 3, because, like I said, we're doing what came out of G of 2. So let me erase this, and then we'll do the other one now. So without using the old formula or the formula we found for this equation, I'm going to do this again. So this we know is G is on the outside, F is on the inside. And so was X is now 2. So we are looking for G of F of 2. So first thing we need to find is F of 2. So F was 3x minus 1. So we're going to have 3 times 2 minus 1. So it's just 6 minus 1, which is going to be 5. So G of F of 2 is actually asking me for G of 5. So G of 5 will just be 5 squared plus 5 minus 3. So that'd be 25 plus 2, or 27. So for your first worksheet problem, we have f of x is 5x plus 3, and g of x is x squared minus 2x minus 2. And we want to find f composed as g composed with f. And then we want to find f composed as g of negative 3, g composed with f of negative 3. Okay. So first one here, we know that if we're doing f composed of g, g is going to be inside of f. So another way to look at this a little different the way I did it before, we know that g is x squared minus 2x minus 2. So that means that for f, I'm just replacing the x with x squared minus 2x minus 2. If I distribute that across, I get 5x squared minus 10x minus 10 plus 3. So this is just 5x squared minus 10x minus 7. Now for g composed of f, we know that f is being placed inside of g. And we know that f is just 5x plus 3. So that means that when I look at g, all the x's in g are now going to be replaced with a 5x plus 3. Okay. So this one, remember, that is going to be 5x plus 3 times 5x plus 3. So we have to expand that. 5 times 5 is 25x squared. 5 times 3 is going to be 15x. 3 times 5x is once again 15x, and 3 times 3 is going to be 9. So altogether, this will turn into 25x squared. Add those 15s, we get 30x plus 9. So for this part right here, I just have to distribute that 2 across. So that's negative 10x minus 6 minus 2. Now if I combine like terms, I got 25x squared plus 20x. And let me see, we'll have negative 3 plus 1. All right, so for the last part, like I said, I'm going to do this the long way again. Not necessarily the long way, but pretend we didn't find this. Like if you use these functions that we made here, that is fine. But just as a reminder that what's inside is the g. So first thing I need is g of negative 3. So negative 3 squared times 2 times negative 3 minus 2. So it'll be 9 plus 6 minus 2, or let me see, 15, so 13. That's going to be 13. So f composed of g of negative 3 is just saying I would need f of 13. So 13, oops, sorry, let me go back there. F is 5. times x, so 5 times 13 plus 3. Double check my math here. 3 times, oops, sorry, 5 times 13, there we go, get the right numbers. Yeah, that was 65. 65 plus 3, that'll leave me with 68. I was double checking. So if I took this formula here and I replaced my x as -3, it was going to be 68. All right, and then the last one, so we have G and then we have F. So we know F's on the inside first. There, I fixed my tool. So we need to find F of -3 first. So we got F is going to be 5 times -3 now plus 3. So that is going to be -15 plus 3. So this is -12. So if we want G composed of F of -3, that means we're looking for G of F of -3. And we know that F of -3 is just -12. So we're looking for 25 -12 squared plus 5. Oops, sorry, I was looking at my composition. Wrong one. I need to look at G. G was -12 squared minus 2 times -12 minus 2. So that is going to leave me with 144 plus 24 minus 2, or let me see, 1, 2, 6, 4, 8, 166.